The second part of the review is going to be about covalent bonding and acidic bonding, which is chapter 3.6. It's a lot easier than ionic bonding because there's only so many elements that can actually be involved. What you do have to remember are the prefixes for 1 through 10. So since we have nonmetals bonding with other nonmetals and they're sharing and not giving and taking, there's no charges. There's nothing to crisscross. There has to be a way to represent why one substance made of nitrogen and oxygen is different from some other substance made of nitrogen and oxygen. So these are the prefixes that we use for simple covalent molecules like this one. So instead of worrying about what charge do these have, they don't have one because right now they're covalently bonded since it's two nonmetals. So we would name this by just putting the prefix in front of the element. So we have dinitrogen pentaoxide. Okay, we're still ending it in IDE, but the fact that there are prefixes is a indicator that this is a covalent bond. And that is different from this one, which is dinitrogen again, but it's trioxide instead of pentaoxide. Okay, so one thing that is an exception is you do not have to say mono for the first element. So instead of saying monocarbon, this is just carbon. But then the second one always has to have a prefix. So that's the reason why carbon dioxide has the name that it has. And that is also the reason why this molecule is well known. Okay, this does have to have the mono because the second element always has a prefix no matter what. So just naming a few more, there is only one for the first element, so instead of monophosphorus, it's just phosphorus, and then pentachloride would be how we finish that. And the last one, okay, this is tricarbon, and then octahydride. Okay, so that was really fast. I'm sure you got it all. Naming acids, the way that you know that something is an acid is if the substance starts with hydrogen. So there are two different types. There are acids that are attached to a pure nonmetal, in which case you would start the word with hydro. And then we follow similar rules, so we're going to use the root word for fluorine, but instead of calling it hydrofluoride, it's hydrofluoric acid. So instead of the IDE, we end with an IC. Another well-known one, okay, this is hydro, and then the root word is chlor, but instead of chloride, it's chloric acid. And there's only so many of these. There's basically just the halogens, hydrofluoric, hydrochloric, hydrobromic, hydroiodic, and that's basically it. If we have a polyatomic ion attached to the hydrogen instead, if the polyatomic ion ends with ATE, we stick with the IC, but if it ends in ITE, we change it to OUS. And the other big difference is that you do not use the hydro part of the name. So, for example, this is not hydro something. This would be nitrate if we were naming the NO3, but we're going to change it to nitric acid. And this one is nitrite, but we drop the ITE and change it to nitrous acid. Okay, two more examples. This is acetate. Okay, we don't use the hydro because we have a polyatomic ion, so we're going to drop the ATE and change it to ic. And so this is acetic acid, which is what vinegar is. And last example, this is called hypochlorite. Change the ITE to OUS, and now you have hypochlorous acid.